All right. So today we're going to continue on with a part of the class that is composed of several uh, smaller, easier modules. And the reason I'm doing this right now is because um, I'm going to assume that many of you have other classes, and in many of those other classes, you might be taking midterms or other things like that. So I like to give you, since I'm not going to give you a midterm, exam, I'd like to give you a little bit of a breather in the middle of the semester, give you a chance to catch up, give you a chance to get your feet under you, and divert your attention to other more urgent classes for a few minutes before we return to something that's a little bit more challenging. So in this module, Module 10, we're going to be covering error handling. And this is another one-day module. We're going to go over both the sandbox and the assignment today. It's going to be a relatively short lecture because there's not a ton of new content for you. It's more conceptual than anything else. So let's jump in. So there are basically two major categories of errors that you're going to get in your programs. The first category of error is an error that you are going to cause through programming that is not correct. Maybe you forget a quotation mark, or you forget a parentheses, or you don't indent the right thing, or you misspell print, or whatever. Happens to the best of us. Those kind of errors are going to happen every time you run the program, no matter what the user does. Now, those kind of errors are ones that you just sort of need to figure out and deal with in terms of your code. The other big category of error, though, is a user-generated error. Okay? Sometimes those are what we call the infamous ID10T errors. If you don't know about the ID10T error, just take a piece of paper and on that piece of paper write in all capital letters ID10T and then read it back to yourself and you'll figure it out. Mostly what I'm talking about are errors that are caused by users. So in other words, if the user does the right thing and behaves the way you want them to when they're using your program, then everything goes fine. They enter an integer when it's supposed to be an integer. They enter a string when it's supposed to be a string. They respond appropriately to menu prompts. Everything goes smoothly. And a lot of times when you're testing your own software that you write, because you know what the developer expected because you are the developer, you're putting the right answers in, your program works great. But then you show it to your friend or your mom or your grandparents or whatever. Grandparents are great for testing software, by the way. Pro tip, because they will break everything. And they all of a sudden put in the wrong thing, which seems so obvious to you. Of course, it has to be an integer, not a decimal, but they do it anyway. Man, I didn't even think about that as a developer. So, what can you do to prevent that second category of errors? We call that error handling. Another word for it is user proofing. Okay? User proofing is important if you're going to be developing any sort of software that people are going to use who aren't you. Because anytime somebody else uses your software, you're introducing all kinds of different possibilities of errors. And so if you don't want your programs crashing and people think you're a bad software developer, then what you need to do is user-proof your software. There are two philosophies for user-proofing. And one of them we've kind of already been talking about.